Let's review what you learned in the Earth's formation video. The key concepts that I wanted you to pay attention to are listed here. Let's address them one at a time. First of all, what is the Big Bang? When did it occur? And how do we know? The biggest thing that we know of is the universe. It's everything that surrounds us. It's the largest thing we know. Here are some of the things that we can see when we look out at our universe. These are nebula that are part of our galaxy, and these are other galaxies that are very far away from us. Now, in 1929, an American astronomer named Edwin Hubble observed that other galaxies were moving away from us. In fact, before that, he realized that there were other galaxies. Everybody thought that we had the only galaxy because we didn't have very good telescopes yet. And some of the things that scientists were able to see that looked like little smudges, they thought were nebula. However, Edwin Hubble discovered that those were galaxies, and he also realized that they were all moving away from each other and from us. Interestingly enough, he did these discoveries not far from our campus at Mount Wilson. So how can all galaxies be moving away from us, regardless of where we look? This implies that the whole universe must be expanding. The size of the universe is not fixed in dimension. It's changing. The analogy that's commonly used is the raisin bread analogy. And so what we have here is a dough with a bunch of raisins in it. And that dough rises over time. Every raisin in that dough gets farther and farther away from every other raisin, just as every galaxy in our universe is expanding and getting farther and farther away from every other galaxy. And that's also shown down here in this little cartoon. The universe, we believe, began 13.6 to 13.7 billion years ago, and it's been expanding ever since, and everything is moving away from everything else. Now, if we look at how everything is moving outwards, and we reverse it backwards, it brings everything to a single point. And that is what we call the Big Bang. The Big Bang suggests that the universe began at a single point and has been moving outwards ever since. And as it was described in the video, the timing of that Big Bang, by using these velocities backwards, is 13.7 billion years ago. Okay, next question. How do stars form? Well, stars form from nebula, which I've mentioned earlier. And nebula are collections of gas and dust that are out there in the galaxies. For one reason or another, nebula start to contract and condense and gravitationally pull themselves together, and then they start to rotate and flatten like a pancake. And they form what's called a protoplanetary disk, a flattened disk that rotates. So where do these nebula come from? Well, many nebula are the remains of stars that have exploded. For example, here's the Butterfly Nebula, which is very far away from us, but in our galaxy. And this nebula formed when a star that was located around this position exploded. And all of this material moving outward is the remnant of that exploding star. This material is now called nebula, and it is the material for the next generation of stars. A supernova is the name we give to this explosion. It's an enormous explosion at the end of only a very massive star's life. So stars have different sizes, and our sun is not massive enough to go supernova when its life is at the end. Here's the Spaghetti Nebula, interestingly named because I guess it looks like a plate of spaghetti. This is a very, very large structure. It takes light 150 years just to travel across it, and light travels very quickly. And so somewhere in the middle here was a star that exploded in a supernova explosion. And all of those little filaments are gas and dust that are available for new stars to form. So the bottom line is, nebula are the result of the death of one star, and they provide the material for the birth of the next generation of stars. Here are some nebula in our galaxy. They're really beautiful, so I'm just putting them in for fun. Here's the Eagle Nebula, a pretty fascinating nebula that the Hubble telescope has taken lots of pictures of. I guess the idea is that this would be the beak of the eagle. And I'm going to zoom in on this thing here called the spire, and then this area here called the pillars of creation. So here's the spire, and this is 10 light years long. This is an enormous structure. It takes light 10 years to travel from one end to the other. course, we're looking on it from the edge, so we're seeing it all at once. All of these little nodules that you see are places where new stars are going to form. If we look at the pillars of creation, again, we see these little nodules where new stars are forming. And I'll zoom in on this top one. And this is what we call stellar nurseries, places where brand new solar systems, star systems are forming. Each of these little finger-like projections will be a new solar system, and currently they are each larger than our solar system. So that's where stars form and how they form. What about the elements from the periodic table? Well, as described in the video, elements up to number 26, which is iron, form by nuclear fusion inside of stars. And again, these have to be massive stars. So here's a cutaway view of a massive star, and hydrogen and helium, the lightest elements, are forming from fusion near the surface. But as you go deeper and deeper into the star, we get heavier and heavier elements, and possibly all the way up to number 26 from fusion. Fusion is taking elements and putting them together because the temperature and the pressure is very, very extreme, and so elements can be fused together. Elements greater than number 26, if you recall from the video, are formed during the incredible energetic process of the supernova explosions. When did our solar system form, and how do we know that age? Well, this is known as the nebular theory. I don't believe the narrator used the name nebular theory. This is what scientists believe is the formation of stars and solar systems, which go hand in hand. First, as that nebula starts to contract and pancake and spin that I mentioned earlier, most of the material goes to the center and gets hotter and denser and eventually begins nuclear fusion and becomes a star, or in our case, the sun. The dust and the material around the outside collides and becomes larger and larger particles to eventually form the planets. So everything in our solar system formed at the same time. Everything in another star system formed at the same time, not necessarily the same time as our system, but our star system all formed at the same time. So everything in our solar system is 4.6 billion years old. Neptune, 4.6 billion years old. Halley's Comet, 4.6 billion years old. Earth, Moon, the Sun, the asteroid belt, Pluto. It's all 4.6 billion years old. And we know that because we've been able to date meteors and asteroids, and they give us an age of 4.6 billion years. Finally, how did the inner and outer planets form? We distinguish these two groups because they're quite different. Above, I have the terrestrial planets, which are closest to the Sun. And if you look at this key here, they're mostly rocky crust, rocky mantle, metallic cores. The Jovian or gaseous planets are shown here, and if you look at the keys, they're mostly gaseous hydrogen, and some strange things like liquid and metallic hydrogen, possibly with a rocky core. So these two groups are very different from each other, and this is because of how they formed. The terrestrial planets, again, are the small, dense, and rocky inner planets, Mercury, Venus, Earth, and Mars. And the gaseous planets are the outer ones, Jupiter, Saturn, Uranus, and Neptune. They're large, low density, and made of gas and ice. Early on in the formation of the solar system, the inner planets near the Sun experienced very hot conditions with a strong solar wind, and that blew away any of the gases that might have been accumulated. On the other hand, the outer planets were far away enough from the Sun that the temperature was cold and the solar wind didn't blow the gases away, and so they accreted. So these two different groups of planets formed because of their different positions relative to the Sun. The next video you're going to watch is early Earth, and here are some things I'd like you to think about while you watch that one. How and when did Earth's core, mantle, and crust form? What did density have to do with this process? How did Earth's magnetic field form? And why was Earth's magnetic field necessary for the formation of Earth's atmosphere? How did Earth's atmosphere form? How did Earth's oceans form? And what evidence do we have for the oldest age of the ocean? So this is your next video.